Okay, now we will go to the image formation by plane surface. We will consider two phenomena where we can see image. First by reflection and second by refraction. Alright, so before we proceed that, let's define what is object in optics. So we have two kinds of object. Either we see the objects because of it is self-luminous. For example, sun, because we see sun because sun emits light itself. Okay, and this is also so we see this LED because it emits light. And second is illuminated. That means the object is being illuminated so that we can see. So moon is an illuminated object because we can only see moon when sun radiates moon with its light, and then we receive the lights from the reflection. And also we can see for example the rainbow because of refraction. Okay, so that means this is the second effect. This is the first illumination from the object itself. All right, so if you look, you can see my hand because my hand reflect lights from environment. So this is the second type of object. All right, okay, now we move to the how we can see object, how we can see image of an object by reflection on the plane surface. So this is plane surface mirror. This is normal. We can see that this is a plane surface, flat. So how we can see our image on the plane surface. So we are going to draw what we call a ray diagram, where we represent light as a ray. Okay, ray diagram. Okay, first let's consider the point object. For example, there is a one object here. We can say this is a tip LED, a small LED, for example. Okay, this LED emits light in all direction. Right, it emits light in all direction, and we see this LED because lights, a part of the lights also go directly to our eyes, and then our friend also can see this because a part of it, a part of the ray also directly go to this eye. So anyone around here can always see this LED, this object, because light from the LED emits in all directions, so everyone can see it. Everyone take a part of it, a part of the ray. Okay, now we have a mirror. We put a mirror, for example, we put a mirror here, for example, and then we still see the image over there. So we can see LED over there. So how can we explain the formation of the image inside the mirror? All right, how? Okay, first let us take only the first ray, which is in this direction. This is the ray, the only one ray. Actually, we cannot count the rays because there's we just represent light with a ray. So we take only a part of the light, and it is represented by this ray. And then what happened when it will get reflected, right? So by the law of reflection, so we have to draw the normal line so we can know in which direction it will be reflected. So the incident angle is 0, so the reflected angle is also 0, so it will get back. Alright, and then we take another, for example, a ray from here to this surface. So let's draw again the normal line. Okay, normal line is 90 degree. Okay, so let's use our ruler to guide us. Okay, and then we have to draw a reflected ray so that the incident angle is equal to the reflected angle. Okay, so I think it's not a good one, so just make it as close as we can. So maybe like this a bit. All right, so this is the reflected ray. All right, okay, and then you see that actually our eye is programmed naturally to interpret that lights coming in straight line. So so our eyes will interpret that this light is coming from somewhere behind. All right, behind. So this is not ray, it's just an illusion line where our eye try to extrapolate that light coming from somewhere behind. Okay, and then this light also, if we look also from here, so we also interpret that this light is also coming from behind. Okay, so I think I make it a little bit away from that. Okay, so like this. So it seems that these lights and these lights coming from one point here, and then our eye will interpret that okay, there is LED in behind. So this LED behind. And also if we draw another point, another ray, for example from here, and then we draw the normal line, so it seems that it goes nicely reflected. So this is incident angle, this is reflected angle. So if we draw all lines, all ray represented light coming from this LED in all direction, someone will look at this reflected ray as coming from behind. So our eyes will create those illusion by as an image eye, and this is object. So we can see that we will see the same thing behind the mirror because our eye extrapolate that so that we can see the same thing. So light hitting and then goes to our eye, reflected back. So because of law of reflection, so there will be incident angle equal to reflected angle. So the law of reflection still applies. So okay, so if we put symbol O as image, this is as object, and I as image, so we can also define another quantity called S as the distance, object distance, and also from here to here as an image distance. Okay, this is image distance, so we can see that S equal to S prime. So for a real object, we call it as extended object. So for example, the this pen, how we can see it as the same thing inside the mirror. So like this. So we can see this is the extended object, and this is a point object. So how we can see that same thing that we use the similar same principle that actually we see something this pen because of lights reflected in all direction from this pen. Okay, so even though there are so many of them, unlimited numbers of ray, we can represent those ray light as ray in all direction. So let's take the one ray coming from here, go directly into toward the mirror, and will get reflected back. Okay, and someone see here as the light coming from behind. And then let's take for example light from here, it is the normal, and then it will get reflected, and it is seen as it is coming from behind. So you see the tip of the pen will be formed here. Okay, and here at the end of the mirror, also at the end of the pen, goes directly and get reflected back. So it will be extrapolated behind, and then maybe one from here will get reflected. so it is interpreted as it is coming from behind. So now the end of the light from here will be formed here. So if we consider all lights for the whole part of the pen, all of them will form image behind. So this is image and this is object. So we see the same thing. Then this is the distance, object distance equal to the object distance, image distance, and also the height is also the same. So we can also define another quantity called magnification, which is also equal to height of the image over height of the object. So it seems that they have the same values, so that in case of reflection by a plane surface, we have magnification is always 1, the same size.